Hi everyone, this is module 1. Today we will discuss the introduction to Python, and we will discuss that what is Python, why we use it, and what is its application in the domain of health sciences. So Python is a high level general programming language, and it is designed to be easy to read and write. It is close to human language, and it is powerful enough for complex scientific and industrial applications. So Python emphasizes clarity and simplicity, and it make it suitable for both beginners and professional level. Python is easy for beginners to learn. Why we use Python? Because it reduces development time, allow rapid experimentation and prototyping, have a massive ecosystem of libraries, and it is supported by strong global community. The advantages are its simplicity, richer ecosystem. There are multiple libraries for data analysis, visualization, machine learning, etc. Also, Python is a cross-platform that it can be run on Windows, Linux, Mac OS, or other operating systems as well. There is a strong community support, and there is integration capability, meaning that the Python can easily be integrated with other languages like C, C++, Java, and other systems like database systems and web systems. Python in health data science. So Python plays a critical role in health and medical data analysis, mean that we can do data analysis of patients in Python. Similarly, we can disease risk prediction. We can do this task. We can also do medical image processing, clinical decision support systems. We can make these type of systems in variable and sensor data analysis. Its ability to handle large data sets, apply statistical methods, and build AI-driven models makes it ideal for healthcare applications. And why it is preferred in this domain? Because it is easy for handling of structured and unstructured medical data, strong libraries for statistical and machine learning, excellent visualization for clinical insights, and rapid model development and testing. So Python enables healthcare professionals and researchers to focus more on medical insight rather than programming complexity. So in the summary, Python is simple, powerful, and versatile. It outperforms many languages in data-centric fields. It is a dominant language in healthcare, science, and medical AI. So this is all about Python. Now, in order to write a Python code, we will not install anything locally. Instead, we will use this Google Colab. You can type it here, Google Colab, and then you can click on this link. Now, if you want, you can sign up or you can directly open Colab from here. Now, I will just click on this. If you have this screen, then you can come click on file and then on new notebook and drive. So this is our IDE, mean that this is a place where we will write our Python code, and this is running on cloud. We do not need to install something in our local machine. So I can write like this, print hello world. I can write like this, and I can press shift enter, or I can just click on this icon to run the cell, and you can see that this line is printed. Now what is this line? So we will discuss it in the upcoming sessions. So for the first module, your task is just to access to this Google Colab and write this line, and from the next module we will learn that how to write a Python code. So this is all for today. Thank you. This is the second module, Python Basic and Syntax. The first topic is print function. Print function is used to print something into our console. For example, I can write the print welcome to data science program. By running this cell, it will print this line into our console. We can print anything that we want. For example, I can print hello world. Also, I can print any number. You can see that this function is used to print anything into our console. What is function? We will cover this in the upcoming modules in great detail, but for now just focus on this one function which is used to print something here. Second topic is comments. I can write print 30. For example, I have a patient and his age is 30. I can specify that here the age of the patient is 30 years. So this line is known as comment. A line becomes comment by placing the hash sign before it. This line will not be executed by our Python compiler. This will be ignored. It is used. For example, I have any member in my team and he just want to write this code that what I have written. This line is for his reference so that he know that this 30 represent the age of the patient. The third topic is arithmetic operations. We can use the Python like a calculator. For example, we can add numbers like 1, like 10 plus 20. And Python will execute it and will give us the answer 30. Similarly, I can subtract numbers 10 minus 5. This will give us 5. We can multiply two numbers, 10 multiplied by 2, 20. Similarly, we can divide two numbers, 10 divided by 5. It will give us 2. It is to be noted that when we divide one number by another, it gives us the floating value. We will discuss that what the floating point number mean in the upcoming module, but for now just notice that when a number contain any decimal, this is known as float. These 10 and 5 both are integers, but when we divide 10 by 5 or when we divide one integer by another integer, it gives us floating value. The last topic of this module is indentation. What does indentation mean? Indentation means leaving some space at the beginning of a line. For example, I will write this code. At this point, you will not understand that what this line means, but it is simple. It just check that whether the value stored in this x it is greater than 5 or not. The point that you should understand is looking to this line, you can see that I leave this space before at the beginning of the line. I leave this space. This is known as indentation. When we enter some block, we should leave this space. You can see that if I run this code, it runs. I do not leave this space, then we will get an error. You can see. So when we enter some block of code, then we should leave the space here. This is known as indentation. This is the module summary. We discussed that Python is interpreted language. It executed line by line. Comments improve code clarity. Print function shows output. Python support basic arithmetic, and indentation is mandatory. This is all for this module, and in the coming module we will learn other topics and concepts that will reinforce our understanding about Python. Thank you. Welcome to the third module. Today we will discuss what is variable and data types. A variable is used to store data in Python. It allows us to save values and use them later. Just like in real life, we use container to store items in it, or just like a bottle which is used to store water. Similarly, in programming languages, there is a concept of variable which is used to store data in it. The syntax of variable is such that first we have to write the name of the variable. For example, first name, this is the name of my variable. Then we have to give the assignment operator, and then we have to write our data. For example, I am going to store here Ali. Now this name, it is stored in this variable. We can check that by the use of print function. We have discussed in our last module that what this function do. It basically prints something into this console. Now you will see by running this code, you can see that this name is stored in this variable. We can give our variable any name, but there are some rules that we should keep in mind. Naming convention for variable. For example, x is equal to 9. This is the value which is stored in this variable x. If we print it, the code will execute as there is no error. The first rule is that we cannot start the name of our variable from digit. If I write 7x is equal to 9, this will give us an error because we cannot begin the name of our variable from digit. If I run the code, we will get an error. This is the first rule. The second rule is we cannot use a special letter in the name of our variable. For example, if I write like this will also throw an error. But there is only one digit which is allowed, that is underscore. We can write like this. This is valid code. Similarly, if there are multiple things that we want to combine, we can use underscore. For example, if I want to write my last name, then I cannot write like this. Space is not allowed in the name of variable. We can combine these two with the help of underscore. This is valid now. Last name is not 9, but now you can see that our code will run. So these are some rules that we should keep in mind in order to declare a name for our variable. In health data science, variables store patient information. For example, I can store the age of my patient in the variable age. For example, it's stored 45. I can also store the weight of the patient, which is, for instance, 70 kg, and we can also store his blood pressure, this variable, which is 120. Now if we want to print it, we can print age, print weight, and print blood pressure. You can see that these values are stored in this variable, and we can access these values with the help of these variable from anywhere in our code. Similarly, we can write like this: the age of the patient is age Now if we run the code, we can give a descriptive form to it. The age of the patient is, and this age will copy the value from here, 45. You can see from here. There is one other way to use this variable in the descriptive form. There is one other way that is known as if strings. If strings are used to place the value dynamically inside a string. For example, I can write print function, then I will write the if, that is for if string, then I will use single quotes or double quotes, and then I can write the age of the patient is. Here we have to give the two brackets, and between the two brackets we will write the name of our variable age. The cure of the patient is basically these both are same. This will print exactly the same as this, but this is another method and this is another method, but both will print same things like this, you can see. Second topic is data types. A data type defines the kind of value a variable can hold in Python. Not all data is the same. There are multiple types of it. For example, integer, float, string, and boolean. An integer is a whole number like patient age or heart rate, for example 45 or 120. Similarly, a floating point number is a number which has decimals like temperature 98.6. You can see that there is a decimal in it. The third data type is string, which is used to store text data like the patient name or comments like these. And the fourth data type is boolean. Booleans store either true or false. So now let's discuss each one in detail. The first data type is numeric data types. Numeric data types are basically these two. These two are basically the type of numeric data type. There are two numeric data types in Python mainly. The first one is integer, which is used to store whole number, and the other one is float, which is used to store numbers with decimal points. For example, I can write heart rate equal to 72. This is basically an integer, and temperature is equal to 98.6. This is float. This is floating point number and this is a whole number. Now we can print both of these variables, heart rate and temperature. You can see these values are stored here. So this is the first type of data, which has, this one is integer data type, this variable have float data type. The next type of data, that is text data. In Python there is a data type called strings, which is used to store text data. Text data in Python is called string. For example, we can write patient name. For example, patient name is Ahmad. Now this is a text data which will be stored in this variable. We can write the text data either in single quotes like this, or we can write the text data inside a single quote. We can write it inside a double quotes, or we can write it inside a triple quotes. This depends upon us. Similarly, this is another example, diagnosis equal to diabetes, and we can print it. So a string variable is a string data type is used to store text data in it. Next type of data type is boolean data type, which can store only two values, either true or false. For example, we can write as diabetes is equal to true or his fewer equal to false. A Boolean data type can only store these two values, either true or false. We cannot store any third type of data in Boolean variables. And we can print it like this. Now the next topic is checking data types using type function. This is basically a function type, and using this function we can check the data type of variable. For example, now we have discussed that this variable has a type of integer. We can validate it. Heart rate, temperature. Here on the cell, sorry, now you can see that the data type of this variable is integer and the data type of this variable is float. We have discussed that here also, that this variable has the data type of integer and this one has floats. Similarly, we can check these variables. For example, patient data. Now if we run the cell, this variable has the data type of string, and we can also check this variable. It has the data type of Boolean. You can see from here. Now let's do one example. Let's collect the data of our patient who have the age of 60 years. His temperature is 99.5. His name is Lee, and he has the diabetes. Now all of these variables have stored different type of data, and we can print that like this. You can see here. So these are all for today. In short, the summary is variable store data. It is not necessary that it store only held data. It can store any type of data. Int and float store numeric values, string stores text data, and boolean stores either true or false values. And type is the function which is used to check the data type of variable. So this all for today. We'll see you in the next module. Thank you. Welcome to the fourth module. In this module, we will discuss input, output, and type conversion. The first topic is input function. This function is used to take input from the user. If you want to take input from the user, we can use this function like this. Input. This is the name of the function, and we can write enter your name. Now by running the cell, you can see then that we can enter our name Ali. Now this function is executed. This is the input and this is the name that we entered. We can store the output of this function in a variable like this, name, and then whatever we get, we can print that into the console like this, name Ahmad, and then this name whatever we enter, this data will be stored in this variable, and then we will print that into the console. So this is the way in which we can take input from the user. We can also take other information, like we can take the age of the user, enter your age, and then we can print Ahmad. Then we can enter the age like 45, and then both of these values will be printed into the console here. The next topic is typecasting or type conversion. Type conversion means to convert one data type into another. First of all, let us understand that why we need to convert one data type into another. Let us consider the input function. For example, I want to get the age of the person is input. Age is equal to input. Please enter your age. When I run the cell, this program asks us to enter our age. For example, I entered 55. Now if you look toward the data type of this variable, we have entered the integer value, but this input function takes everything as a string. You can check the data type of this variable like this: type of age 34, and you can see that though we have entered an integer value, but this function considered the integer as string, and now the data type of this variable is string. But if you think the age is a number is integer, not a string, therefore it is required to convert this string back to an integer. This is known as typecasting or type conversion, to convert the data type of a variable into another data type. How to do that? If you want to convert input or other data type into an integer, we can write like this: we simply have to write int here, and this int function will convert these thing into an integer. Now if I run the cell, you can see that now the data type of this age is integer. Why? Because we have converted the string into integer using this function, integer function. Similarly, we can convert, for example, the height of the person is, please enter your height. Now when the person enters his height, it will be a string, so we have to convert that into a float. So we will write the float function like this: GHT. And now by running the cell, your age is this and the height is 5.3. And now you can see that first, when we enter our height, this is considered a string, but then this function converted the string value into a floating point number, and you can see from here. Similarly, if I have a number weight is equal to 60 kg, and if I want to convert this number into a string, I can also do that like this. I will use the string function str. This function will convert this value into a string. If I want to check the type, then I can do so. Now here we have stored the integer value in this variable, but using this function it converted the integer back to a string. You can see from here. Now the next topic is displaying formatted output. We have discussed this topic already in the previous module, but for now we will discuss it again. For example, I want to output or display the values of this variable into my user. I can do that using two methods. The first method is I can write the age of the patient is, then I have to give comma here, and I have to write the name of the variable, which is age. Then I can write and his height is this and his weight is this. So by running the cell, you can see the age of the patient is 34, his height is 4.5 and his weight is 60 kg. This is the first method. I can also use the if string method. If string like this. Print function. Then I can write like this. The age of the patient is this and his height is this and his weight is this one. This is first method, this is the second method, but both of these work the same. You can see both printed exactly the same thing. Last topic of this module is simple health example BMI calculation. This is actually a mini project. You can calculate the BMI of a person using this formula. So we will write it here. BMI is equal to weight divided by height multiplied by height. And we can print the patient's BMI is BMI. Now if we run the code, we will get patient BMI is 2.9, this value. Now if you look toward this, there are multiple numbers to the right side of this decimal. We can control that. We will give the colon sign, then we have to give dot, and then we will specify that how many numbers do we want to the right side of this decimal. For example, I want that there should be 3 digits only. Then I will write 3 and F. Now if I run the cell, it will give me only 3 digits after the decimal point. So this is all for today. The module summary is input function is used to take input from a user, and we can typecast or we can convert one type to another using integer function, float function or string function. Displaying results using formatted output. There are two ways that we have discussed, and at last we have done a mini project. BMI calculation combines all concepts. That's all for today. Thank you. Welcome to the fifth module. Today we will discuss basic data structures. A data structure is a structure that is used to store data. Data types, there are two data types in Python. The first one is primitive data type and the second one is non-primitive. Primitive data type is used to store single data in single variable, while non-primitive data type is used to store multiple data or multiple items in a single variable. We have discussed already these in our previous sessions, and today we will discuss non-primitive data types, list, tuple, and dictionary. The first data structure is list. List store multiple items in a single variable. Items can be numbers, string, or mixed, or it can also be floating point values. First, you should know that why we use list. For that, for example, I have the data of my 3 patients. I can store their data as patient. Let's suppose I have their ages. Patient 1 age is equal to 20 years. Age of the second patient is 30 years. And the age of the third patient is 40 years. So I can store their ages like this in separate variables, but I can also store their ages inside a single variable, and that will be the power of using list. So to declare a list, first we should give it a name, then we have to put this assignment operator, then we have to put these brackets, and inside the brackets we can store our data. For example, 20, 30, 40. If we want, we can store any numbers, 50 or 60, 70. So these all are the information of the patients which we stored inside a single variable. This is known as list. We can print the list patient, which is, so you can see these numbers are stored in this variable. Now if we want to extract individual number from this list, we can do that with the help of indexes. The position of this number is 1, this number is at second position, this number is on third position, but the index start from 0. The index of this number is 0, index of this number is 1, 2, 3, 4, and 5. And we can use the indexes to extract individual items from this list. For that, first we have to write the name of the list, then inside these brackets we will use the index of the element that we want to extract. For example, we want to extract 20 as its index as 0, we will write here 0. Then if I run it, you can see we have extracted 20 from this list. Similarly, if I want to extract the second number, I can extract that its index is 1, so I will write 1 here. It will extract 30, which is the second element. If I want to extract this item, then I can do that also. The index of this number is 0, 1, 2, 3, 4, 5, so I will use 5 here. You can see we have extracted this item. So using indexes to extract element from a list, this is known as indexing. Indexing is used to extract a single value only. If you want to extract multiple values, we can also do that, and that is known as slicing. And its syntax is, first we have to write the name of variable, then we have to write these brackets, and inside this, for example, I want to extract these 3 values at a time, not just a single value but multiple values. I will write the index of this number, which is 0, then I will give this colon mark, and then if I want to extract 3 values, then here I will write the index of this number. So the index of this number is 4, 0, 1, 2, 3, sorry 3. I will write 3, and it will give me these 3 items. By running the cell, you can see we have extracted the 3 values from this list successfully. You should note that this is excluded and this is included. The index third index in this list is of this number, but this is not included, this is excluded. That's why we have extracted only these values. If we want to extract these values, we can also do that. Print from 0 to 0, 1, 2, 3, 4, 5, 6. We will write like this: 0, 1, 2, 3, 4, 5. Not 6. We will write 5. You can see we have extracted these values from the list. There is a concept of negative indexing. So for example, I want to extract the last element from this list. There are two methods. The first method is I use the positive indexing: 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5. So it will give us 70. Another method is to use a negative indexing. Negative indexing start from the reverse of list. This is a negative index of 1 minus 1. This is at the negative index 2, which is minus 2. So we can extract this number using negative indexing like this: minus 1. This also give us 70. If I want to extract this element but using negative indexing, I can also do that: minus 1, minus 2, minus 3, minus 4. I will write minus 4 here, and this will give me that number respectively. You can see we have extracted 40 from this list. So this is all about the first data structure, which is list. We can, if you notice here, we have stored integer values in the list only, but this is not required. We can store any type of value. For example, I can have a list x is equal to, for example, the name of the person is Ali, his age is 40 years, and his height is 5.6. So we can store any type of numbers like this. Now we can print this. So we have stored these value inside a single variable, and the remaining is the same. If you want to extract only his name, you can write like this. If you want to extract his height, there are two methods that we have just discussed. You can use the positive indexing like 0, 1, 2, or you can use the negative indexing like this: x minus 1. Both of these will give us the same value, which is his height. Now there are some basic methods that we should be aware of. Basic methods or operations. For example, there are 3 elements in this list. Let's suppose I want to add the weight of the person as well. So I can write x dot append. This is the method or operation which is used to append element at the last of this array. So x dot append, for example, the weight of the person is 50 kg. So by running this line, it will append the value 50 to the last of this array, and by printing the array, you can see that this 50 is added to the last. Similarly, we can also find the length of the array. To know that how many elements are stored in this array, you can use the length function, length x. So this gives us 4. You can see there are 4 elements in this array. If you want to check the first array, that how many numbers are there, you can copy this name, print length of this. So it shows us there are 6 elements in the first array, which you can validate from here: 1, 2, 3, 4, 5, 6. So this is all about list, and now we will discuss the next data structure. Next data structure is tuples. Tuples are like list. It also store multiple values using a single variable, but cannot be changed after creation. Last time you have seen in list that once we have created this list, we were able to append element to it. But this will be not the case with tuples. Once we have created a tuple, we cannot append element to it. So basically this is the difference between list and tuple. A list can be changed after its creation, while the tuple it cannot be changed. The syntax of the tuple is such that first we have to write the name of the tuple. For example, patient info, patient information. This is the name of the tuple. Then we have to give this parenthesis, and then we can store the information. For example, the name of the patient is Ali and his age is 30 years. So basically this is the tuple. You can print it. You can also check its type using the type function. So you can see that this is a tuple and there are two values that is stored here. You can also extract this element and this element using the concept of indexes. Index of the first element is 0, while index of this element is 1. You can write like this. So we have successfully extracted this element, and using this line of code we have extracted this element. The next data structure is dictionaries. Dictionaries is another way to store multiple values using a single variable. Dictionaries store the values in the form of key value pairs. Keys are unique identifiers and values can be of any data type. The syntax of dictionary is such that first we have to write the name of the dictionary. For example, the name of my dictionary is patient information. Then we have to give assignment operator, and when we declare a dictionary we have to use the curly braces like this. Inside this we have to give one key and one its value like this. For example, the name of the person is Khan. Then we have to give this comma. His age is 40 years, and let's say his gender is male. Similarly, his height is 5.3. This gives us an error because we forget to place a comma here. Okay, so this is basically a dictionary. We can print it like this. So this is basically a dictionary. These the values at the left side of this semicolon, these are known as keys, and to the right side of the colon, these are its values. Now there are some methods that is also defined on dictionary. For example, if we want to extract all the keys, we can extract that by the use of a method. First we have to write the name of the dictionary, and then we will use this method to extract all of the keys. So these are the keys, dictionary keys: name, age, gender and height. You can validate from here: name, age, gender, height. Similarly, there is another method that is used to extract the values from this dictionary. By running this line of code, it gives us all the values in a list. Similarly, we can also use the concept of indexing here. If you want to extract this single value, instead of using indexes, we will use the name of the key, which is a name. So this will give me the value of this name. If I want to extract this 40, this is a value, I will use its key, which is age. So this give me 40. Means that we can extract any of these values by using its key name inside this. For example, we can extract the height, the value of height as well, which is 5.3. So this all about dictionary, and in the module summary, list store multiple items can be changed, use indexing or slicing, and these are the two methods that we have discussed: append and length. Tuple store text data cannot be changed once created, and we can use indexing. We have also discussed this one. Dictionaries use data in the form of key value pairs, access and update. We can access the value like this. It should be access, not index. And we can also update the value like this. If I want to update this name from Khan to another name, I can do that. First, I will access name, and for example, I will give Khan. So when I run this line, this name will be updated. Oh, sorry, this is already Khan. I will place Ali. So this Khan will be updated to Ali. And when I print the dictionary again, you can see that first Khan is stored, but when I run this line, it is updated to Ali. You can see from here. So in a dictionary, store value, key value pairs, access and update values, and these data structure help manage multiple patient records efficiently. This is all for today. See you in the next module. Welcome to the sixth module. Today we will learn about decision making, conditional statements. This module introduces conditional statements used to make decisions based on medical data. In real life, we often come across a situation where we take decision based on some condition. For example, if condition is met, then do this, and if the condition is not met, then do this. In programming language, we can take decisions based on some condition also, and this is done through if-else statement. So the first thing is if statement. The if statement execute code when a condition is true. For example, I have a heart rate. I have a variable that stored the heart rate of a person. For example, it is 110. Now I want to check that if is a heart rate is greater than 100, I can print high heart rate detected. Now when I run the cell, you can see here heart rate, it is currently 110 is stored in the heart rate variable. Is 110 is greater than 100, so this line will be executed. If I run this cell, you can see that this line is executed. Why? Because this condition is true. 110 is greater than 100. If I change this 70, now you can see that 70 is not greater than 100, so this line will not execute. You can see it prints nothing. So this is the first thing, and this is the first statement in the if else ladder, that if some condition is true, it will execute this line. Second thing is if else statement. For example, I want to check that if is a heart rate is greater than 100, then print high heart rate detected. And if the heart rate is not greater than 100, then print normal heart rate. Now let's change this into 110. Just print this cell. Now you can see as 110 is greater than 100, this line executed. Now if I change this to 90, now 90 is not greater than 100, so this line will not be executed while it will execute this line. You can see normal heart rate. So based on this condition, we are now able to take decision. If this condition is true, do this. If this condition is false, then do this. Now if there are multiple conditions, we can also use that in our if else later. For example, if I want to check, for example, I have a variable which store the blood pressure and I stored 120 in it. Now I want to check that if blood pressure is less than 120, print low blood pressure. Elif means else if blood pressure is less than 140, then print normal blood pressure, and if it is greater than or equal to 140, then print this line. Currently let's store 100 in it, and now you can see that 100 is less than 120, so only this line prints. If I change this to 130, then this line will print normal blood pressure, and if I change this to 150, then the else part will run and it will print this line, high blood pressure. So if there are two conditions, we wrote like this. Now we can use as much as elif statements as we like. For example, we can also write a blood pressure is less than this is the correct statement. So 150 is less than 160, so now it will print this line, and if I change it to 200, then this line will print it. We can use multiple elif statements, but there should be only one if statement and one else statement, and we can write this as much time as we want. The next topic is comparison operator. Comparison operator is basically, for example, I have a variable x equal to 10. Now if x is greater than 5, print x is greater than 5. Now this is the comparison operator. Greater than, this is for greater than, and this symbol is for less than. X is less than 5, then print x is less than 5. Similarly, this is equality operator. This is equality. It basically checks that whether this value equals to this or not. Similarly, this is greater than or equal to, and this is less than or equal to operator. So basically these are the comparisons operator which is used in this part of the if statement. This is the conditional part. So these comparisons operator are used to check the conditions. For example, I want to check that whether x is less than 5 or not. So if I run this, is x is equal to 10 and it is not less than 5, so this line will not be executed. If I change this to 1, then 1 is less than 5, so this value will execute. This line of code will execute and it prints x is less than 5. The next operator is next topic is logical operators, which is basically and or. So if I want to combine multiple conditions, then we will use the logical operators. For example, I have a variable age is equal to 70 and I have this boolean operator is diabetes and I set it to true. Now if I want to combine both of these conditions, if I want to take decision based on both conditions, not one, here we take decision based on only this variable, but now we will take decision based on both of these variables. Like this, I will write if, then the first condition we will write in this parenthesis. For example, is if age is greater than 70 and is the logical operator, then we will write the next operator and has diabetes equal to, then we will print this line. Now you can see and is the operator. Basically both of these conditions will emerge to one condition. If this conditions become true and this condition also become true, then only this line will execute. But if any of the condition between both of these become false, then this line will not be executed. This is the significance of AND operator, that it only becomes true only when both of these conditions are true. Now you can see that change this to 90. As 90 is greater than 70, yes, this true, and has diabetes, this is we set it to true also. So both of these conditions are true, now this line will execute. You can see if I change this to 60, then 60 is greater than 70, which is false, so this one become false, and this one is true, so this line will not be executed. The second logical operator is or works opposite to AND. Or is executed if any of the condition between these two become true. If this is false but if this is true, then this line will print, or if this become false but this become true, then also this condition will executed. And if both are true, then this line will print. If both are false, then this line will not be executed. For example, it will execute this line though this condition is false, but as this one is true, so this line will executed. You can see from here. So both of these are logical operators, or and. The last topic is race classification. This is basically a mini project. For example, here we are given the condition classify patient risk based on blood pressure. So we will take one variable that will store the blood pressure, and then we will classify based on by take decision based on this variable, that if blood pressure is greater than is less than 120, then print this line, else print high risk. Now is 90 is not 90 is less than 120, so this line will print. If we change this to 140, then this line will print. So we have basically made a risk classifier, and this classifier take decision based on this variable. So this all for this module. We have learned if, elif, else, control, flow structure. We have also talked about comparison operator, logical operator, and its use in the real time risk classification. So that's all for today. Thank you. Welcome to module 7. Today we will discuss loops for health data processing. In programming languages, there is a concept of loops which is used when we have to do the same task but multiple times. In health data science, we often need to repeat the same operations for many patients. Whenever there is a case when we have to do a same task multiple times or for multiple patients, then using loops, it is an effective method. For example, in the first topic, for loop, you have to learn the syntax for loop. Syntax. There are other type of loops also, but today we will discuss only the for loop. For example, I have a list and it stored the values like this. Now I want to extract all of these items one by one. So the first method that we have previously discussed is we can extract each element using the concept of indexing. Like this. The remaining code is the same, but only we have to change the indexes. If I run it, you can see we have printed or we have extracted all of these elements. This is first method that we have discussed earlier, but this is not an effective method because if you look at all of these 5 lines, all the code are same, only there is a difference in indexing. So we can extract all of these elements with the help of for loop like this. The syntax of the for loop is first we have to write the for keyword, then we have to write the name of variable. For example, the name of my variable is I. Then we have to write the in keyword, then we have to write the name of the list or name of the sequence that we want to extract items from, list 1, then semicolon, and in the next line we will write our logic that what we want to do. Now simply I will write like this, and if I run this cell, it printed or it extracted all of these elements. Now the question is that how does it works? So in the for loop, this variable I take the first value I equal to 1, and then this line prints the value of I. Then the value in the second step, the value 2 is assigned to this variable, and this line prints this value 2. Then in the third step, this 3 is assigned to I, and the fourth step 4 is assigned to I, and the fifth step 5 is assigned to I, and this line prints whatever is stored in the I variable. So that's how it works. Second type is looping through a list. I think we have covered this here, but somehow let's go through it. For example, the heart rate of the patients are 72, 88, 102, and 95. We have 4 patients and their heart rates are these numbers. If you want to iterate over all of these, or if you want to extract all of these, then we can write the logic like this. First, this variable will take this value, then in the second step 88 will assign to this variable, then 102, and then 95 will assign to this variable, and simply this print function will print whatever is stored in this variable. So we have extracted all of these numbers. So the third topic is looping through a dictionary. Let's make a dictionary first. For example, we have a dictionary patient information, and it stores the name of the patient, the age of the patient, his gender, and his heart rate. Now if you want to iterate or if you want to extract all the keys and all the values from this dictionary, we have to write the logic like this: patient's information and print I. Now if I run this cell, you can see that this dictionary there are 2 things. One is the keys and the other is values. If you look toward here, it only prints the keys but not the values. If we want to print the values also, then we have to write here another variable, but we have to use the method of a dictionary that is known as items. And basically this methods return the key as well as its value from this dictionary. Now if we write here key is equal to I and value is equal to, not is equal to, this sign will be great, yes, we will read this one. Now you can see in the first place the key is name and the value is Ali. Key is name and the value is Ali. Similarly the remaining one. So this is a method, or this is the way through which we can loop over a dictionary. The next topic is simple statistic use case checking abnormal heart rate values. This is the mini project. For example, we have the heart rate of patients. Heart rates equal to 70, 100, 90, 110, 120. Now first of all we will extract each of these elements like this for I in heart rates. Now we will check that if heart rate is greater than 100, if I is greater than 100, then we will print abnormal heart rate detected. But if this is not the case, then we will only print I. This line will only execute only if this condition meets. If any of this number is greater than 100, then only this line will execute. And by running the cell, let's remove this one to make confusion. So there are two values which are abnormal. One is 110 because this value is greater than 100, and same is the case with this value. So there are two values, heart rates, which are abnormal, and the remaining three is normal. From this example you see that how we use if statement with for loops. Now the next topic is break statement. For example, so I will copy this one. If for example I want to make a logic that if any abnormal heart rate detected, then break the program. Mean that if any of the value is greater than 100, then break the loop and do not go further. So for that, this logic is the same as above, only we will add the break statement here. And basically this, what this key will do, that if is any value that is greater than 100, then it will stop the loops to move forward. For example, you can see from here that as long as first this 70 is assigned to this I, then 100 is assigned to this I, then 90, but it didn't did anything. But when this value assigned to 11, this condition become true and it breaks the loop. You can write like this. Like this, you can see that these values executed successfully, but as long as 110 is assigned to I, then this line executed and it break the flow, and this this item didn't get a chance to be assigned to I. Similarly, this is break statement. Now there is another statement known as continue statement. What does it actually do? Continue skips the current iteration and moves to the next one. For example, these are the heart rates. I have written this logic that if any of the heart rate equals to 0, then don't do anything. Skip that iteration and go forward. Then if I run this cell, you can see 72 is assigned to this variable and it prints here 72. Then when this rate equal to 0 and this condition met, then it just skip the 0. Here you can see that 0 is not printed and it moves forward. 88 is printed and then 95 is printed. So this is continue statement which skips the current iteration if the condition is met. The module summary is we have learned loops, how to iterate through list and dictionaries, and we did a basic project, and then at last we learn break and continue statements. That's all for this module. See you in the next lecture. Thank you. Welcome to module 8. Today we will discuss about functions. This is the most important concept in programming. Function is basically a block of code that performs a specific task, and it can be used whenever needed in the program. So how to define a function? A function can be defined by writing first the def keyword, then we have to write the name of our function. For example, the first function that we want to make will be the greet function. Greet, this is the name. Then we have to give these parentheses, and after the colon we will write here the logic of the function. For now, this is the simple function. We will just greet someone, hello. So this is the function. Now if I run this cell, this hello will not be print because we have made the function, but until now we didn't call it. In order to execute the function, we should call it like this, greet. Now if I run the cell, these two lines will execute like this. You can see that these lines executed. This is the simple function. We can make another function, greet. Its name is greet2, and we can print hello world. And when we call it, you can call it like this, and you can see hello world. So this is the method to build a function. First you have to write this def keyword, def, then the name of the function, and here we will write our logic. Function parameters. Parameters allow us to pass patient's data into a function. For example, I want to make a function, again the greet function. But now I want to greet someone. I want to greet my patient. I want that when I call this function, I pass the name of someone. For example, Ali. Now, how will I get this name here? For this, I have to write the name of some variable. It may be any name. So I will write name, and here I will write hello, and I will use that name. Now if I run this cell, it will print hello, and whatever I passed from here, this will be printed here. You can see hello Ali. If I write like this, similarly if I make another function, greet, similarly I can pass multiple parameters like this, hello, name, your age is this one. Now when I call it, I will pass two parameters. The first one will be the name, the second one will be the age. If I run this, hello Ali, your age is 25. We can pass multiple parameters as much as we want, but we can write the third parameter, fourth parameter, and so on. And then there is a return statement in the function. For example, I want to make a function that will basically add two numbers. So it will take two numbers, this input, and it will add those two numbers. Add is equal to a plus b, and then we want that whenever we call this function, it gives us back, it returns this value. So we will write the return add. And now when we call, for example, 5 and 1, it basically returns 5 plus 1 6. So we can store this in another variable. For example, x is equal to this one, and we can print x. So basically it print the 6. So this return keyword basically return whatever we write here. We can also do this one. We can pass any value, and this function will add both values and will return their sum. Another example is the risk classification function, classifying patient risk using blood pressure. So this function classify risk. This function will take the blood pressure of a person and will classify that whether his blood pressure is normal or not. So if blood pressure is less than 120, it will return low or normal, else it will return high or risk. So we will call this function classify risk, and we will pass 100. So this return normal because 100 is less than 120. If I pass 140, then this will return this value like this. Next example is average patient value function. Calculating average heart rate. For example, we have many patients and their heart rates are 72, 85, 90 and 88, and we want to make a function which will give us the average of these values. So define def average value is the name of the function. Then it will take this list as an input, and then if the average value is 0 for now, we will learn a loop to extract each of these value. For value in values, total is equal to total plus value. So we will extract each of these values one by one and will add to this variable. So first time 72 will add to 0, then 85 will add to 72, then the result of this will add to this one, and the result of these three will sum up with this one. So this give us the total heart rate. Then we have to return the total by the length of this array. of this list values. Sorry. So now if I call the function average values and I pass this list, this will calculate the average value of all of these traits like this. Now if I want to add another value, I can do. If I want to change it or write another value, I can also do this. So this is the average patient value, the average patient value function. In the summary, we learned function help reuse medical logic. DEF is used to define a function. We learn how to use parameters and how to use the return keyword. Functions are essential in health data science. So this is all for this module. Thank you. Welcome to the 9th module, built-in functions for data analysis. These are the functions that is defined on list, but it is very helpful in data analysis. This module is just to reinforce your understanding about functions. The first function is length. You can see this is a list. If you want to know that what is the length of this function, we can simply write the name of this list and we can use this length function to calculate its length. By running this cell, you can see that this will return total patients for the length of this list is 4. The second function is sum. It calculates the total of numeric values. For example, this is the list which contains 4 values, and if we calculate the sum, it will give us the total, which is equal to 357. Similarly, these are the min and max function. Min function calculates the minimum value. It returns the minimum value out of this list, and it will give us the maximum value. Lower BP 110 and highest BP 140. The round function is used rounds a number to the nearest integer or given decimal places. For example, this is 23.678. If we put 1 here, then 23.6 will print only this. After the decimal, only one digit will print. You can see. If I write 2 here, then 0.67 will print. 0.68 printed, basically it rounds up. If I write 3, then all of this will print. If I write 4, then I write 5, then only this will print. Similarly, this is the sorted function, sort list in ascending order. 25.7, there is no order in this list. If we apply the sort function to it, it will arrange these values in ascending order. You can see 25, 40, 65, 70. And this is the mini example, calculate average heart rate of patients. So this is the list which have the heart rates. It will calculate a total. This will count how many patients are there in this list, and this will calculate the average. So the average heart rate is this one. Basically, these are some functions that is used, and these functions are really helpful in data analysis. So practice on these functions. We will provide you all of the module. So do practice on these functions. It will help you a lot. In the module summary, length, sum, minimum, maximum, round, sorted. These are the functions that we discussed. That's all for this module. Thank you.